All right, we are going to solve this next system of equations. We have a line and we have something else. It's not actually a parabola. It's one of our conics. It might be an ellipse or a hyperbola. So it doesn't actually matter. We can solve this algebraically without knowing what exactly the shape is. So what we're going to do is we're going to solve one of these. I'm going to pick this top equation and solve it for y. So we have negative y equals negative 2x minus 3. And if we divide everything by negative 1, I get y equals 2x plus 3. I am going to plug that in here for y. So that'll give me 2x squared plus 4x minus 2x plus 3 squared equals 0. Okay, so now that we've got that plugged in, we're going to keep solving. I'll get to that minus sign in a minute. I need to distribute this. This is 2x plus 3 times 2x plus 3, which is going to be 4x squared plus 6x, which is 12x plus 9. If you need to write that out, 2x plus 3 times 2x plus 3, and do the whole FOIL, please do that. I did it a little bit in my head. And then we're going to distribute that negative sign. All right, let's get our like terms together. We get negative 2x squared minus 8x minus 9. Let's see, let's factor out a negative 1. 2x squared plus 8x plus 9. Now, I don't think that that can be factored, because if you try an umbrella factor, you get 18, and there aren't any factors of 18 that add up to 8. So we're going to have to use the quadratic formula. All right, so we get x equals negative b plus or minus the square root of b squared minus 4ac. I'm going to put that directly into my calculator just so I don't have, mistakes with my math. So 8 squared minus 4 times 2 times 9 is going to be negative 8. All over 2a, which is 4. Now, from the quadratic formula, since we have a negative 8 under the square root, the solutions are imaginary. And so we're able to say no real solutions. Okay, we do have imaginary solutions, but in this case, we were just looking for real ones, and we don't have any. So these two graphs, this line and whatever this turned out to be, they do not intersect, and that does happen. So we might have two solutions, might have one solution, we might not have any. All right, let's go back to that word problem at the beginning of the notes. We're investing $25,000 into two different funds, 6.5% and 8.5% simple interest. The formula for simple interest is I equals PRT. We've got principal, rate, and time. And our total interest is $2,000. How much is invested at each rate? All right, well, let's think through this a little bit. We need to figure out how much we're putting in each account. So I'm going to call X the amount in the 6.5% account. And Y is going to be the amount that I put in the 8.5% interest. So let's see what I know about these. I know that the amount that I put in each account adds up to $25,000. And I also know the interest from each account, interest plus interest, is $2,000. Now, the way that I calculate that interest is I take the principal, so the principal was X. The rate was 0.065. Time is just 1 year. Plus my principal on the second account is Y. Interest is 0.085, and I leave that in there for 1 year. All right. So now I rewrote that equation. So this is these are my two equations. So what I can do, let's switch colors here, is I can solve this for one of the variables. Let's say that I just want to solve for x. I'm going to subtract y from both sides. And then I can plug that in down here. So I get 25,000 minus y times 0.065 plus 0.085y equals 2,000. All right, I'm going to distribute here, and I don't know what $25,000 times 0.065 is. Okay, it is 1625 minus 0.065y plus 0.085y equals 2,000. I'm going to combine my like terms. So that gives me 0.02y. And I'm going to subtract that 1625 to the other side. 375. And so I'm going to write this over here. Y equals $18,750. So that's how much I put into the second account. And then we go back and I would plug back into this original equation here to find out how much we put in the other account. And it turns out to be $6,250. Okay, so similar problem, we're just using substitution to solve this.